Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one question lost more marks than any other on last year's AQA higher paper, a simple parabola that students were asked to sketch. Why did so many lose marks? Because they dropped the constant when they completed the square and ended up shifting the graph the wrong amount. If you know one reliable algebra trick, make it this, completing the square. It turns messy quadratics into neat vertex form and gives you method marks almost every time.
Section 1. The concept. Let's work through this step by step. Start with a general quadratic, ax squared plus bx plus c. The goal of completing the square is to rewrite it as a times a perfect square plus a constant. We call that vertex form, a times x plus h squared plus k. Why do we care? Because h and k are the x and y coordinates of the vertex, the turning point of the parabola. Here's the algebraic move. First, if a is not 1, factor it from the x squared and x terms. Ax squared plus bx plus c becomes a times bracket x squared plus b over ax, then plus c. Inside that bracket, we want to create a perfect square trinomial. Take half of the coefficient of x inside the bracket, that's b over 2a, and square it. Add and subtract that square inside the bracket, but keep the equation balanced by applying the factor a where needed. Concretely, ax squared plus bx plus c equals a times bracket x squared plus b over ax plus b over 2a squared plus c minus a times b over 2a squared. The bracket is now a perfect square, a times x plus b over 2a squared plus c minus b squared over 4a. That final constant, c minus b squared over 4a, is the vertical shift k. So the vertex is at x equals minus b over 2a, y equals c minus b squared over 4a. Let that sink in. Rewriting exposes the vertex immediately.
Now, 3 short worked examples so you can see this in action. First, a simple one. X squared plus 6x plus 5. A equals 1, so half of 6 is 3. Square that to get 9. Add and subtract 9. X squared plus 6x plus 9 minus 9 plus 5 equals x plus 3 all squared minus 4. So vertex form is x plus 3 all squared minus 4, and the vertex is at minus 3 minus 4. Second, a not quite one example. 2x squared plus 8x plus 3. Factor 2 from the first 2 terms. 2 times x squared plus 4x plus 3. Half of 4 is 2, square is 4, so 2 times x squared plus 4x plus 4 plus 3 minus 2 times 4 equals 2 times x plus 2 all squared minus 5. Vertex at minus 2 minus 5. Third, a negative leading example. Minus x squared plus 4x minus 1. Factor minus 1. Minus times x squared minus 4x minus 1. Half of minus 4 is minus 2, square 4. Minus times x squared minus 4x plus 4 minus 1 plus 4 equals minus times x minus 2 all squared plus 3. Vertex at 2, 3. Each step is reversible and each arithmetic adjustment matters. That dropped or misapplied constant is exactly where marks disappear.
Section 2. The exam technique. Here's where the marks are. For a typical 3-mark vertex question, you'll often see M1 for the correct rearrangement to show a completed square, M1 for isolating the constant term or identifying the vertex coordinates, and A1 for the final correct answer. Examiners want to see the completed square itself. Don't skip it. If you write only the final coordinates without showing the completed square, you risk losing an M mark. So write the step where you produce x plus h squared or a times x plus h squared plus k. That's method on a plate. For solving quadratics, marks follow similarly. M1 for forming the square, M1 for taking square roots correctly, A1 for the solutions. Even if your arithmetic slips at the end, the M marks can still be secured by neat correct algebraic steps. AQA, Edexcel and OCR all follow this principle. They award method marks for correct process even when the final number is slightly off. Write it down, don't just think it. Common marking pitfalls to avoid.
1. Dropping the constant adjustment when you add and subtract the square. That changes the vertical shift. 2. Failing to factor out a when a is not 1. 3. Not labelling your final vertex clearly as a coordinate pair. If the question asks for maximum or minimum, give the vertex and say whether it's a maximum or minimum based on the sign of a. Examiners love this one. Say vertex at HK, minimum since a is positive. Short, clear, precise.
Section 3. Quick win and practice. First, your 30-second checklist to verify a completed square. 1. Check the perfect square inside. Expand x plus h squared to make sure it gives x squared plus 2hx plus h squared. 2. Ensure any factoring of a has been applied to the constant adjustment. 3. Confirm the vertex coordinates by using h equals minus b over 2a and k equals c minus b squared over 4a as a quick cross-check. That checklist will catch about 90% of careless slip errors in under half a minute.
A mental shortcut for speed when a equals 1. Take b, halve it to get h dash, square it to find the added term, then move the constants. In other words, for x squared plus bx plus c, vertex form is x plus b over 2 squared plus c minus b over 2 squared. For a not 1, do the same inside the bracket after factoring a. Practice a couple of quick questions now. I'll talk through the steps so you can time yourself. Practice question 1. Complete the square and find the vertex for x squared plus 6x plus 5. We already did this earlier, but practice under exam timing. Half of 6 is 3, square is 9. So write x squared plus 6x plus 9 minus 9 plus 5 equals x plus 3 squared minus 4. Vertex at minus 3 minus 4. Label it clearly and box it. That step, writing x plus 3 squared minus 4, is your M mark. The coordinate is your A mark. Practice question 2, slightly harder. Complete the square for 3x squared minus 7x plus 2 and find the minimum. Start by factoring 3 from the x terms. 3 times x squared minus 7 thirds x plus 2. Half of minus 7 thirds is minus 7 sixths. Square that to get 49 over 36. Add and subtract inside the bracket. 3 times x squared minus 7 thirds x plus 49 over 36 plus 2 minus 3 times 49 over 36. That bracket is x minus 7 sixths squared. Now simplify the constant. 2 minus 3 times 49 over 36 is 2 minus 49 over 12, which equals 24 over 12 minus 49 over 12 equals minus 25 over 12. So result is 3 times x minus 7 sixths squared minus 25 over 12. Vertex is 7 sixths minus 25 over 12, and because the leading coefficient 3 is positive, it's a minimum. If fractions feel slow, practice a few fraction examples at home. The method is identical. The arithmetic just needs careful handling. Time management tip. If a question looks like it will be messy, write the first line clearly and box your completed square before doing the arithmetic. That way you secure the M marks quickly and can tidy the arithmetic if time allows. And remember, same method, different numbers. Do the square inside the bracket first, then deal with the constant. That's your quick win for today. A 30-second checklist and a mental shortcut to check your completed square. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable Completing the Square worksheet at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.